This is the pride of Germany. The long-standing rival of SANY and XCMG, since its establishment, has consistently ranked among the top 3 in the world. Just a single vehicle frame requires over 1,000 independent components, and it achieves all-wheel drive steering through electro-hydraulic control. Thus, it allows the vehicle body to achieve a wedge shape with the smallest turning radius. Next, let's see why Liebherr, known as the light of Germany, maintains its strong position. The most important and unique step is the telescopic boom. Workers first lay the steel plates on a framework. After a period of adjustment with traditional techniques, it is shaped and formed. Once the assembly is complete, the telescopic boom weighs over 60 tons in total, meaning each section has a neck weight of 10 tons. From the outside, it doesn't seem as heavy as one might imagine. Next, the bushings soaked in hydraulic fluid at -196 degrees are removed. Before any damage occurs, quickly place it inside, then install a large steel spring and a positioning metal shaving weighing up to 140 gin. This process is quite labor-intensive, and you can even see the workers' faces turning red and necks straining. The outer layer's robust spirit highlights the meticulous precision of the inner layer. The surface is made of polytetrafluoroethylene, and the white plate is the key material used for anti-slip purposes. You should know that the most wear and tear on a crane doesn't come from the gears inside the gearbox, but rather the white anti-slip plate on the telescopic joint shown in the footage, which is of utmost importance. Whenever it operates fully loaded, it acts as a shield to prevent metal friction, especially in the scene before us. In the initial design, a large gap is usually reserved, and polytetrafluoroethylene can conveniently be used long-term in environments ranging from 180 degrees to 260 degrees. It also has a nickname, the King of Plastics, which is the core secret to the durability of the telescopic arm. With such a large space inside, how can it extend and retract freely? Let's look at the screen, where we see a hydraulic cylinder. Each section of the telescopic arm is connected to the cylinder. When the equipment is activated, the hydraulic pump pushes hydraulic oil into the cylinder, synchronizing with the operator's controls to achieve the lifting purpose to whitey. Now, the gear plate is being installed, which is the first component of the control room. Inside, there are multiple sets of ball bearings consisting of inner and outer parts. The inner ring is fixed, while the outer ring can rotate. The body is made of alloy steel, and it takes half a month to complete, so you will find this set of gear plates particularly different. Here is the control engine, and the crane is equipped with 2 sets of units. The upper engine is used to provide power to the hydraulic pump and works in conjunction with the winch, so it typically uses a 435 horsepower 6-cylinder diesel engine. It is not responsible for driving, only for lifting. Next, the chassis is installed on the frame, which is crucial for the vehicle's movement. The main frame is equipped with 9 sets of axles, collectively known as the all-wheel steering system. During the vehicle's movement, wheels turning in the same direction can minimize friction to the greatest extent, which means achieving the smallest turning radius in narrow spaces. This is especially beneficial for diagonal driving, making it a blessing for drivers. Moreover, this technology is not only seen in trucks, it is also experiencing an explosive growth in domestic new energy vehicles. Then the main frame is rotated and flipped over, to begin installing the driving engine for the vehicle body. Compared to the previous set, this engine appears more compact, and its surface lacks the intricate piping and countless wires, featuring only one engine connected to the transmission to provide power to the 9 sets of axles. A ruler is used to measure the spacing for the engine, truly showcasing the impressive precision and beauty of German manufacturing. Displayed to the fullest extent, even a deviation of less than 0.5 centimeters must be carefully corrected. It seems that only one country can compete with this, using a crowbar to align the drive shaft into place, and then securing it firmly with just 4 screws. The winch was also installed at this moment. In the blink of an eye, we completed the main structure of the vehicle body. For this, we installed the final components. The cab appears to be designed with lower dimensions, lacking the tall and imposing stature of a mining truck. The internal space also seems more compact, yet the visibility is excellent. It is driven by a dual hydraulic and electric control system, and the wheel hub can also steer in different directions, simultaneously further enhancing flexibility and comfort. Now, tires are being fitted onto the wheel hubs. The primary function of the tires is to support the vehicle's own weight of over 100 tons, rather than the additional weight when transporting cargo. Compared to the previous King of 100 tons, it indeed appears safer. After all, back then, the King of 100 tons only had 3 or 4 sets of wheels, yet dared to haul hundreds of tons of cargo everywhere. Next, the steel strands are hoisted onto the vehicle body. From the outside, it looks like an ordinary steel cable. But using the same formula and method, the result is distinctly different. It's like how the United States goes to great lengths to purchase arresting cables from within the country. The key technology will always be in the hands of a few major countries, and it is also the secret formula for a company to reach its peak. Next, let's move on to the final assembly. The object in front of us, which resembles an octopus, is the hydraulic landing gear. It is integrated with the upper control room. So the landing gear is part of a unified hydraulic oil control system that raises and lowers the equipment. When the crane is loaded, it can lift the vehicle body. To prevent the tires from bearing the gravitational distribution during the loading process, having just the telescopic arm is far from sufficient. It is also necessary to equip the landing gear with 2 hydraulic cylinders. From the appearance alone, this thing is 6 meters long and 50 centimeters wide. In terms of weight, each one weighs 2.5 tons, which is more than double the weight of a small private car, and most of it is made of a solid structure. The extension angle is about 86 degrees. Once the 2 are assembled, the giant telescopic arm is also sent in. They have their own method for assembling this thing. First, they use a crane to lift the front and rear sections separately, and it requires two people to coordinate throughout the transportation process. Once it reaches the preset position on the vehicle body, grease needs to be applied. First, both side bushings are coated. The grease not only reduces friction, but also provides effective lubrication. At this point, you can carefully and slowly assemble, with each step calculated to be precise, making it appear quite smooth. Lubricating oil should also be added to the bushing of the front cylinder, to reduce the probability of friction. In fact, Liebherr has always held a significant position in the foreign heavy industry market. Apart from their cranes, another must be their excavators. Large tonnage excavators are often involved in mining, construction, and other fields. However, due to fierce competition, Liebherr does not have as broad a market position domestically as Sany, XCMG, and Zoomlion. But its international market reputation is quite impressive. Now let's complete the final test. This guy has an extension height of over 150 meters. The lifting tonnage is not much, with a maximum load of 800 tons, driven by both electronic control and hydraulic systems, and it can even move sideways like a crab. However, this mode of movement is not very fast, and is mainly designed to handle narrow and complex terrains. At this point, we have completed a mobile crane